Have you ever wondered how the computers we use today came into existence? Our journey begins in the 19th century with a man named Charles Babbage. Babbage, often considered the father of the computer, conceived a device known as the analytical engine. Though it was never built, the analytical engine was a mechanical marvel designed to perform complex calculations using punch cards, a method still in use a century later. Fast forward to the 1940s, the birth of the first actual computer, the ENIAC, or Electronic Numerical Integrator and Computer. Built during the height of World War II, the ENIAC was a colossal machine, occupying a staggering 1,800 square feet and weighing almost 30 tons. Despite its size, it was a technological titan, capable of solving a wide range of numerical problems at lightning speed. And so, with the advent of the ENIAC, an unprecedented era of technological development was ushered in. The first generation of computers, starting from the late 1940s, was defined by vacuum tubes and punch cards. In this era, computers were gigantic machines, taking up entire rooms with their massive frames. These colossal structures were heated by vacuum tubes, thousands of them, that served as the nerve center, processing information at speeds unthinkable at the time. Still, these speeds were just a fraction of what our pocket-sized smartphones can achieve today. These vacuum tubes were the predecessors to the transistors and microprocessors that power our modern devices. However, they had a significant drawback: their propensity to overheat and fail. The consistent need for replacements made maintaining these early computers a labor-intensive task. Programming these behemoths was a far cry from the high-level languages we use today. The first generation primarily used assembly language, a low-level programming language that directly corresponded to the machine code instructions that the computer hardware could understand. This made programming a complex and painstaking process, requiring a deep understanding of the hardware's inner workings. But how were these computers used? One of the most notable examples was during World War II. The Electronic Numerical Integrator and Computer, or ENIAC, was one of the earliest examples of these first-generation computers. It was employed to perform complex calculations for artillery trajectories, a task that would have taken humans hours to complete but could be done in mere minutes by this electronic marvel. Punch cards were another defining feature of this era. These cards, filled with holes representing data, were fed into the computer to execute programs. Each card was a physical representation of a line of code, and a large program could require hundreds or even thousands of these cards. The first generation of computers was a testament to human ingenuity and the drive to push technological boundaries. Despite the challenges and limitations, these machines laid the groundwork for the computing revolution that would follow. The end of the first generation marked the beginning of a new chapter in the world of computing. From the 1950s to the 1970s, the world of computers underwent a dramatic transformation. In the blink of an eye, we transitioned from the colossal, room-filling machines of the first generation to sleek, desktop-sized marvels. In this journey, we traversed through the second, third, and fourth generations of computers, each era marked by significant technological advancements and novel programming languages. The chapter of the second-generation computers began in the late 1950s. Here, vacuum tubes were replaced by smaller, more reliable and energy-efficient transistors. These transistors were the game changers. They were not only cheaper, but also generated less heat, increasing the overall lifespan of computers. During this period, magnetic cores were used for internal storage, which was a significant upgrade from the punch cards and magnetic drums of the first era. Simultaneously, the realm of programming languages saw the rise of high-level languages like Fortran and COBOL. Fortran, standing for Formula Translation, was designed for scientific and engineering computations. On the other hand, COBOL, short for Common Business-Oriented Language, was developed for business data processing. These languages opened up new avenues, enabling users to command computers without needing to master machine language. As we moved into the 1960s, the third generation of computers came into the picture. Here, transistors were replaced by integrated circuits or silicon chips. A single integrated circuit could house hundreds of transistors, leading to the miniaturization of computers. This was the time when keyboards and monitors started becoming standard interfaces, replacing the punch cards and printouts of yesteryears. The programming landscape evolved further with the advent of languages like BASIC and ALGOL. They were easier to learn and use, expanding the user base of computers beyond just scientists and engineers. Then came the fourth generation in the 1970s, where the integrated circuits were replaced by microprocessors. A microprocessor, also known as a CPU or central processing unit, is a single chip that houses thousands of integrated circuits. This era witnessed the birth of the personal computer. Computers were no longer exclusive to large corporations or research institutions. They began to make their way into homes and schools, becoming a common part of everyday life. The fourth generation also saw the development of the C programming language. C was revolutionary because it combined the power and flexibility of assembly language with the ease of use of high-level languages. It became the foundation for many modern languages, including C++, Java, and Python. The fourth generation of computers set the stage for the personal computer revolution. Just as the butterfly emerges from the cocoon, the world of computing had metamorphosed, ready to spread its wings and soar into a future of endless possibilities. The late 1970s and 1980s saw the rise of personal computers and the birth of the internet. This era marked a significant shift in the world of computing, bringing it from the realms of academia and industry into our homes and offices. The advent of personal computers cannot be discussed without mentioning two tech giants, Apple and Microsoft. Apple's Macintosh and Microsoft's Windows operating system revolutionized the computing landscape. These machines, with their graphical user interfaces, were far more user-friendly than their predecessors, making computing accessible to an ever-widening audience. While personal computers were taking the world by storm, another significant development was taking place: the birth of the Internet. This global network of computers, originally conceived as a means for researchers and military personnel to share information, would soon transform every aspect of our lives. The Internet's early days were dominated by text-based interfaces, but the advent of the World Wide Web in the early 1990s brought with it a graphical, user-friendly way to navigate the Internet's vast resources. This development, coupled with the proliferation of personal computers, democratized access to information and communication in unprecedented ways. But the personal computer revolution and the birth of the Internet were not just about technology. They were about people, about society. They revolutionized the way we work, the way we learn, the way we communicate. They brought about the information age, where knowledge is power, and where access to information is as vital as access to clean water or electricity. This era of rapid technological advancement also saw the rise of a new kind of professional, the software developer. As personal computers became more powerful and the Internet more pervasive, the demand for software to run on these platforms exploded. This led to the rise of the software industry, creating a new economic sector and countless jobs. The personal computer revolution paved the way for today's digital age. It's hard to imagine a world without personal computers or the Internet. They've transformed our lives in ways we could never have imagined, and they continue to do so each and every day. As we move forward, the future of computers and programming holds immense possibilities. Imagine a world where computers aren't just tools, but intelligent entities capable of learning, evolving, and making decisions. This is no longer a realm of science fiction. With the advent of artificial intelligence and machine learning, we're stepping into an era where computers will not only process data, but also understand, interpret, and respond to it in ways we've never seen before. Quantum computing, another frontier in the computing world, promises to revolutionize the way we process information. Traditional computers use bits, which can either be 0 or 1. Quantum computers, on the other hand, use quantum bits or qubits, which can be both 0 and 1 at the same time. This simultaneous existence, known as superposition, allows quantum computers to solve complex problems at a speed that's currently unimaginable. But what does this mean for programming? Well, as computers evolve, so must the languages used to communicate with them. We're already seeing the rise of quantum programming languages tailored to harness the power of quantum computers. Similarly, as artificial intelligence and machine learning become increasingly prevalent, programming languages that can effectively handle these technologies will become more and more important. The future also holds the promise of more intuitive and user-friendly programming. The rise of low-code and no-code platforms is making programming more accessible, allowing people with little to no coding experience to build applications, create websites, and automate processes. This democratization of programming could lead to an explosion of creativity and innovation as more and more people are able to turn their ideas into reality. And let's not forget the role of ethical considerations in the future of computing and programming. As these technologies become increasingly powerful and pervasive, addressing issues around privacy, security, and fairness will become more crucial than ever. As we stand on the brink of a new era, it's clear that the journey of computers and programming is far from over.